Now we will be going into the seed testing procedures. So talking about seed testing, I would see that what are the objectives of seed testing? So first of all, seed testing determines the suitability of planting. Okay, the suitability of planting means how much seeds do we need to plant during the sowing. So if the germination is less, maybe we have to put more, increase the seed rate so that the population is maintained. If the germination is very high, we can do with lesser seed rate. So the suitability of planting. So is it suitable for planting, or how much should we plant? So this is one of the primary objective of seed testing. The report will give us. And then we have to identify the seed quality problems. Is there any issues with germination? Some issues with physiological conditions. If there are some abnormal seedlings or something like that, to meet the leveling specifications. So every seed lot that is being packed inside packets and being sold in the market will have a leveling specification. So there will be minimum limits of germination, so that packet should have seeds which are having a minimum of some X amount of germination, maximum some percentage of inert matter, and all these different kind of seed quality attributes. So the level standards are already there for each different crop. To meet these leveling specifications, seed testing is necessary. Then also one of the most important testing that are done during a seed testing, a general seed testing, is seed moisture. So do we need to dry? Because if we are packing wet seeds, then after maybe few months, all the seeds will be dead. So is there a need for drying? Those things will also be determined by seed testing. And I'm telling you, there are different kinds of seed. The seeds are already, there are standards that at how much seed moisture content the seed should be packed inside the moisture vapor proof containers. If you are storing the seeds under sealed plastic packages, there is a standard that the seed moisture content should not be above a certain limit. So normally for cereals and all these, for pulses and all, it should not be above 6 or 7%. And for moisture vapor permeable containers like in cloth bag or jute bags, they are normally around 9 to 10%. This is not a thumb rule, but there are different crops are having different standards of moisture content at which you can pack the seeds. And then the basis of the price. So based on the seed quality, the prices are determined. So taking into account all these things, these are the objectives of seed testing that are normally there to do this operation. And seed testing is a very organized operation. You can see that in many cases, if seeds are moving from one country to the other without there are certain certificates that are international certificates that are involved. Without those certificates, which are issued by specific laboratories accredited by specific organizations, and they issue the seed testing report. And without these certificates, the seeds cannot move from one country to the other. So these are the most, just to explain about, you don't have to learn this by heart or something like that. There are so many different international organizations for seed testing, but the most important seed testing organization that normally majority of the countries are following it is the International Seed Testing Association, or the ISTA. You can see on the right. So these are the international rules for seed testing. These are all updated every year, and you can see the list here. So these are normally the American Seed Testing Association, the Association for the Official Seed Analysts, AOSA, AOSCA. The European Seed Association is also there, which are also a body that implements quality seed accreditation, quality seed laboratory accreditations also within Europe. The ILAC, or the International Laboratory Accreditation Corporation, they are the people who are accrediting any kind of laboratory or calibration laboratories all over the world, within which seed is also a purview. But the International Seed Testing Association, the last one you can see, so they are the biggest body, which are, I would say, they are controlling the seed movement or accreditation, or conferring quality and giving training and to all different kind of member countries. The headquarters of ISTA is in Zurich, in Switzerland, and they have different committees with which they are also doing a lot of research in terms of seed testing. So in a nutshell, these are all the international organizations who are involved in seed testing and who are involved in different aspects of seed testing. Some are a body which regulates the country's seed movements. Some are an international organization who are accrediting laboratories. Some are also issuing certificates. ISTA issues ISTA and ISTA accredited laboratories are issuing orange certificates so that the seed can move from one country to the other. So every seed movements will require the orange certificates. So these are the, in a nutshell, these are the international organizations which are involved in the seed testing, and those who are implementing different kinds of laws and regulations for seed testing. So now talking about this, what we are going to do is we're going to learn a little bit about seed testing. And seed testing is done in a seed testing laboratory. So within a laboratory, everything, it happens in a very specified, or I would say in a very organized manner. There are three very important things that are necessary in a seed testing laboratory. First of all, the organization. So everyone should be responsible, and everyone should know about their skills, know about their responsibilities and the skills. There should be an organogram, who reports to whom, and how the flow of information and the information flow happens, and the division of labor, who is doing what, who is doing which testing. This is very important, because there are things that we need to be very careful about time, when the sample is going in, when the sample is coming out, when we are starting the test, when we are stopping the test. So all those things. And then the most important, of course, the testing procedures. The testing procedures should be robust and based on standard methods. So like ISTA, the International Seed Testing Association, have their all these standard operating protocols on how to do germination testing, how to do seed moisture testing, how to do physical purity testing. So these are all there, and these are based on many years of research. They have standardized these protocols. So we have to have robust and based on standard methods. And this test has to be easy to perform, and there should be reference to work instructions. There should be work instruction, so that there should be written somewhere that I should be able to refer that, okay, what temperature should that be, at what time should I be taking the seeds out, what seeds at what temperature, which species I should put at for how long. So all these things, and there should be a defined workflow. What workflow it should be defined, when is doing what, that I just shown in a flow diagram. Then comes the documentations. The documentations are very much important, like the control of records. These are all based on the International Standards Association, ISO. Control of records, we should have data recording and data entry procedures, temperature data, calibration data, then the equipment data. So all these things has to be there inside the laboratory. Non-conformity plan, how we will be handling if some test errors were there while doing the test. So all these things has to be there. And the results handling, what are we going to do with the result? If the results are not done in the right way, should we communicate or should we do the retesting? So all the decision making, it should all should be specified. Now let us come to the seed testing workflow in a nutshell. So first of all, it starts with sampling. So the sample actually comes as a submitted sample inside the lab. So in the field itself, or wherever the samplers are doing the samplings, the unit that is being packed and sent to the lab is called the submitted sample. But the submitted sample is also more than enough. It has enough quantity that will not only suffice the testing, but also it will suffice some of the seeds that can be kept as an insurance. Suppose we lost some of the samples. So submitted samples are normally a little bit over than what it is really needed. And so we need to reduce it to a working sample. In a thumb rule, normally we halve it. So we take half and we use it as a working sample. So we work with those working samples. So how much should be the submitted sample for every crop and how much should be the working sample? These are again specified in the seed laws of ISTA seed rules. So what should be the submitted sample? What should be the working sample? All these things are again specified. So like there are for some crops you need 1 kilogram of submitted sample and the working sample is 500 grams. For some the working sample, the submitted sample is 100 grams because small seeds, and the working sample is somewhere around maybe 50 grams or 30 grams. So we have to reduce the sample, so the working sample. And after reduction, the first test that is done is the physical purity test. I'll go into more details of the physical purity test, but in general, physical purity test, the working sample is divided into inert matter, other seeds, and pure seeds. So the pure seeds are separated, and the other seeds that are not conforming to that species, and inert matter like broken seeds or muds or mud balls or stones or plant parts, all these things are the inert matter. So it is separated, weighed, and percentages are calculated. So this is a physical purity test. Now these pure seeds are used for germination test. So this, many people ask that why is it is not used, because a seed sample may have many kind of inert matter. So those inert matter, if I'm directly using for the germination test, it really messes up the whole workbench. So it is better to work with a cleaner sample. So the germination test is, we have to remember that the germination test is always done with the pure seed fraction. After we do the physical purity test, the small sample packet which contains the pure seeds are taken to the germination test table. So from here the germination tests are actually done. And of course the moisture test, we have to determine the moisture. There are again standards that to have, if you want to do moisture test, the seeds should be packed in moisture vapor proof containers. So you cannot just put it in a paper packet and send it to the lab, because on the way while it is coming to the lab, it will again release the moisture or absorb moisture, and there will be errors. We will never know that what was the exact moisture content at the time of when the sample was packed. So we have to remember that whenever, if the client or the person asks for moisture test, we should remind them that the sampler should put the sample inside a moisture vapor proof or a plastic container or a metal container, aluminum foil pouch, which is not pervious to water vapor. And then the health tests are there. You can perform many health tests. Normally the cold tests are there, in which you can perform the health test, but health test requires quite a high amount of expertise, as well as it needs equipments like microscopes and media preparation and ultraviolet light, so that you can incubate the seeds and all these things. So yes, the seed health tests are very important, which can show you that are there any kind of seed-borne diseases inside the seeds, and what is the microbial flora of the seeds. So there may be some saprophytic fungi or some other fungi which are may be harmful, may not be harmful. At least we'll get a health report of that. And of course the genetic purity test, many places we call the grow out test. It is also performed, which is also part of the seed testing procedure, where the sample is actually planted outside in the field, and they have counted, and how many plants or seedlings are conforming to that particular variety is calculated, and we can say that okay, there are some mixtures or off types or not, some other species are there or not. So this confirms the genetic purity. So these are the total seed testing workflow, the total amount of different kinds of tests that are already performed. So first of all, we need to know the seed sampling is very important. The seed sample, it should be a representative of the whole lot. So this is how you can see that there are sampling triers are used. So these are pipe like slotted equipment with which you can insert it inside the bulk or insert it inside the bag. You can see here, and you can pull the sample. And also, if the seeds are not that much bulky, you can use these methods like the spoon method or the modified halving method and the hand halving method. These methods with which you can actually collect the sample, then reduce the sample, then pack it and send it to the seed testing laboratory. We can now see a small kind of a video with which you can see that how exactly the seeds are sampled. So this is a sleeve trier. You can see these slots. In these slots, actually, the seeds are actually falling inside this pipe, and it is actually a concentric kind of there are two sets of pipes. One pipe goes inside the other, and it can close and open based on where you want the samples to be. So you can see this. Yeah, so now it is going inside. So the sleeve is inserted inside the slotted tube, and the slots can be opened by turning. So now you can see when you're putting it inside, the slot should be closed. Once it is inside, you have to rotate it and open it. And then the sample will fall inside the tube. And now you take it out. See, then you close the bag so that no more seeds are coming out of it. And then you take out the sample and then collect it. So we come to the next test, that is the physical purity test. So physical purity test is actually when the seed first comes in, the working sample is taken, and then this working sample is taken on a workbench, and it is separated into pure seed, other crop seeds, weed seeds, and inert matter. So objective is to conform to the prescribed physical purity standards with regard to the physical components. The physical components we are talking about. So the method consists of the working sample, and it is separated into pure seed, inert matter, and then the fractions are weighed and expressed in percentage by weight. It is quite very simple. You can see from this picture that this is the whole working sample in which it is being separated into. You can see these small small pans in which the broken seeds. So there is a rule regarding the physical purity, that if a seed is broken more than half, so if the more than half is missing, then it is considered as an inert matter. But if it is less than half is broken off, it is considered as a pure seed. So this is a tricky thing. But regarding the regular seed, but otherwise you can easily identify the weed seeds, the inert matters, that is the broken. You can see from here the result. The inert matter is there, the weed seeds are there, other crop seeds are there, and this is the pure seed. So these fractions are again weighed, and the percentage is calculated based on the submitted sample. So the seed germination test is again the pure seed fraction is taken, and the seed germination test is conducted using the pure seed fraction. So there are different methods by which you are doing seed germination, because the seed sizes are different. And if you are not doing the right, taking the right substrate, or the process is not done in the right way, the seeds will not germinate. You will not even get a right result. So based on the size of the seed, so very small seeds who need light, the seed testings, the germination test is done on top of the paper. You can see this picture on a Petri plate or on a similar kind of a tray like that. You have to put the seeds on a moist filter paper, and then you have to put it inside the incubator. And there is another thing called the between paper. So here what you do is you take two moist paper rolls, put the seeds inside and roll it inside. So you can see that these are the testings that are done between paper, medium size, and most common method of doing any kind of seed testing is a between paper method. Very reliable, and it doesn't require much space and all. And which are very big seeds like maize and big beans, these the kidney beans, corn. So these seeds these are very large. It is very difficult to germinate them in between paper, but it is very easy to do it inside. So there is these things are always done in such a way so that the maximum amount of moisture, is available for the seed coat to imbibe. And the next very important thing is the seedling evaluation. So we have done the germination. How are we going to interpret the reports? So the International Seed Testing Association has a handbook, or the ISTA handbook on seedling evaluation, where for most of the species that are grown in the world, the images of how the seedling should look, if we want to classify them as an abnormal seedling or normal seedling or dead. So these all are there. But in general, it is always something like that if you can see that the root system and the shoot system is well defined, then it is a normal seedling. But if you see, you can see here in this picture that the shoot system is developed, but the root system is not developed. So there are some kind of physiological disturbances within the seeds which are not allowing it to develop into good roots. And you can see, of course, the dead seeds you can identify. So within the paper, if you just press, there will be some kind of a liquid oozing out. So you can find out that easily that there is some bacterial or fungal infection within the seeds and the seeds are dead. So this is how we are going to do the seedling evaluation. Again, normally ISTA recommends that we should test 400 seeds. So 100 seeds in 4 replication, and then we make the calculations to as a percentage. So we count all those 400 seeds and we determine that how many are abnormal, how many are dead, how many. There is also a concept called the hard seeds. The hard seeds are having dormancy. So mostly in many pulses, seeds are really hard so that they don't allow water to imbibe. So these are also counted and expressed in the report. So the seed moisture testing is again another very important method or a very important test, which is actually an amount by weight of water that is present in the seed plot. So within the seeds, what is the percentage of water that is present? And the most two very common method by which it is determined in the laboratory. Firstly, it is the hot air oven method. So in this method, actually this is the most accurate, one of the most accurate methods, and it is recommended by ISTA. In this method, the seed moisture is removed by drying the seed sample at a specified temperature for a specified duration, and we calculate the weight before drying and after drying. So we remove all the water, and there are again standards. ISTA has specified standard that what seed should be kept at how much temperature. So normally there are 2 different methods. So we keep the seeds at 103 degrees centigrade for 5, 6, or 7 hours for longer. So it is called the low constant temperature oven method. So at a lower temperature, we keep it for a longer time. These are normally done for the oily seeds, where if you do go for high temperature, then the oil will also evaporate and we'll have a false result, and we'll find out that, okay, that oil percentage was also as moisture percentage. So we just want to evaporate the water, not the oil. So, and we have the high constant temperature method, in which we keep the seeds inside that oven for around 3 hours at 130 degrees centigrade. So this is normally done for these starchy seeds like corn, maize, rice, and even pulses. So this is a hot air oven method with which we calculate the moisture content, and there are so many moisture meters. Moisture meters estimate the seed moisture very quickly, but it is not very precise, because the properties are by which these moisture meters are calibrated, or these moisture meters are manufactured, it depends on some other property which indirectly relates to the water. So like there is one equipment that determines the moisture based on the resistance. So higher the moisture, higher the resistance in the seeds. And another moisture meter that determines the moisture based on the capacitance. And again, so the capacitance varies when the water content inside the seeds are increases or decreases. So these are the different kinds of methods by which these moisture contents are measured. So let us watch a small video again on how the oven method for moisture content is actually is done. So you can see that this is the oven. Yeah, you'll set it to 130. Yeah. So it is set at 130. And we have to weigh the samples. Normally it is done in 2 replicates or 3 replicates. The more the better, but normally 2 replicates are taken. So this is the moisture content. It is called on a wet basis. So weight of the wet grain, weight of the wet grain, weight of the dry grain divided by the weight of the wet grain. So this gives the moisture content. So you can have 3 samples, 3 replicates, and then you do the average. That is how it is done. So now the report compilation, this is very important. Then we get the results of the physical purity, we get the result from the germination, we get the result from the moisture, and these are actually the results that are required for the labeling labeling requirement. So any kind of seed that are sold in the market, these are the most important parameters that should be there in the label, and then finally the report is generated. So let us see the documentation flow in a seed lab, how it happens in a flowchart basis. So first of all, the submitted sample. So this is a submitted sample. It enters the lab, and we have to remember these things because this is the lab workflow. So then the sample is entered in the registers. Now this can be done on a register, or there can be a software with which you can enter the information, and the lab reference number is generated. This is very important. The samples are coded so that just to avoid conflict of interest, any kind of thing. So it is just so that none of the analysts who are working in the lab can know that whose sample or what crop. They should not be able to know what samples or which company's seed this is. So everything happens on a lab reference code. So the coding is done by the lab manager only. So now again the sample is divided normally into 2 parts. So we have the working sample, and rest is kept as a guard sample. The guard sample is kept so that just in case we have to do a retest, the test has gone wrong, or we lost the sample or something like that, we have to keep as an insurance, because maybe those seeds are already sold and already finished in the market. We cannot get our hands on that sample again. So that's why we have to keep this guard sample, and then of course the working sample. Now from the working sample, the seeds will go to the germination test, physical purity test, and moisture test, which I have already explained. The physical purity test happens, and then the pure seed fraction goes for the germination test and moisture test. So this goes to 3 different tables for analysis. And then what happens is that after the results are entered, and there's a job card kind of a thing also. So there's a card that moves with the sample, where everyone at the end of each step, they enter the results. And if you don't have a job card, this also can be done in a software, in a tablet, where all the results of the sample is automatically compiled. So you can enter that, and then this result is actually checked once by the lab in charge. The lab in charge will check, and then the final result will be generated. And again, this can be done manually through the register, or it can also be done through software or by the computer. Anything is allowed, and then it is reported. Reports are generated. The report goes to the client or the customer, whatever, to the farmer or to the agriculture department, from whoever the sample has been received. So the seed law will always have a provision of the quality assurance, and there will be many bodies which are responsible for seed certification and issuing of the certificates, and also the supply of the early generation seeds like the breeder seed, foundation seeds, etc. And this is actually required for the seed law enforcement. So summing up, we have talked about the seed quality assurance in general. We have also talked about the field inspection. So now you have a very nice idea on how to do the field inspections. And since all the protocols and the procedures are already there, there are approved and tested international procedures are there for field inspections. The field inspection and the lab test report, these things combine to form a certificate. So the final seed certification is actually a combination of the field inspection report and the seed testing lab report. So combining all these things becomes the certification. So that's what I wanted to talk about. And now I think you will be able to have your, if you are enough capable to make your own seed testing laboratory, and you can run the own seed testing laboratory based on the procedures that I have just explained. And there are other methods and other procedures which I will be elaborating again later on a separate platform. Thank you very much.